Hey guys, this is AS Chemistry naming organic compounds. The general method of naming organic compound is this concept right here, which says that ABC is known as the prefix. This parent carbon chain is known as the stem. This ane and ene is known as the stem suffix. And this functional group right here is known as suffix. Let's start off with stem first and I'll get back to prefixes. Stem is the number of carbon atoms in the largest carbon chain, and the stem name depends on the number of carbon atoms. So if there is one carbon atom, then this is meth. If the chain has two carbon atoms, then it's eth. If there is three carbon atoms, it's prop. Four carbon atoms in a chain means but. Five carbon atom in a chain means pent, and six is hexane, seven is heptane, and so on. So I have this chain right here, and there is only two carbon atoms. That means this is eth. This has 1, 2, 3, 4 carbon atoms, and you can see that 4 carbon atoms is but, so this is but. Now comes the stem suffix. The stem suffix is the type of carbon to carbon bond. When there are all carbon to carbon single bonds, it's going to be an AN or ane. When there is one carbon to carbon double bond, that would be ene. And when there is two carbon to carbon double bonds, it will be a diene. Let's say I have this structure formula right here, CH2 double bonded to a C, double bonded to a CH, and CH3. This displayed formula would be like this. Now there are two double bonds. There are two C double bond C. Therefore, it's going to be a diene. The stem suffix will therefore be diene. And there is the longest carbon chain has 4 carbon atoms. This longest carbon chain has 4 carbon atoms. So it's going to be but. And the stem is but. The stem suffix is diene. So I write but, diene. Let's do a bigger carbon chain now. You can see in this displayed formula, the biggest unbroken carbon chain has 5 carbon atoms. And since there is only one double bond, you'll write ene. So the stem suffix, therefore, is going to be ene. Remember that you'll always put digits beside the ene. Before you write ene, you'll write digits. And the number of digits depends on the number of double bonds. If you have two double bonds, you'll write 2 digits, where x represents a digit. Now, the value of x, meaning 1, 2, 3, 4, will depend on the position of the double bond. So the number tells the position of the double bond. This x tells the position of the double bond. And we always start from the side that gives the smallest number. We want this x to be as small as possible. We want the value of x to be very small. So which side do we start from? Do we number our carbon atoms from here or from here? We'll number the carbon atoms such a way that this value of x will be very small. If I start from here, then this would be carbon 1, this would be 2, this would be 3, this would be 4, and 5. And the carbon to carbon double bond is between carbon 3 and 4. So x is 3 right here. Let's say instead of this carbon being carbon 1, I start from this carbon. I start from the right. Therefore, this would be carbon 1, this would be carbon 2, this would be carbon 3, carbon 4, and carbon 5. And you can see that the double bond would start from carbon 2. So x here is 2. Which one is the smaller value? This one, right? If I start from the right, if I start from this carbon, then I get the position of the ene starting from carbon number 2. But if I take this as my carbon number 1, then the position of the double bond would start from carbon number 3. Here you can see that if I take right as my carbon number 1, my double bond starts from carbon number 2. And since this is the smaller carbon, my x would be 2. And then we put a dash between alphabets and numbers. So I put a dash and write ene. And since this is 5 carbon atoms, it's going to be pent. I put a dash since this is an alphabet. I write 2 dash ene. Let's do this one last example. I have this 4 carbon chain and 2 double bonds. Since there is 2 double bonds, the stem suffix would be diene, since two double bonds refers to diene. Stem suffix is diene. I have 4 carbon atoms, so this would be but. And since there are 2 double bonds, I will have 2 numbers or digits before I write my diene. Now, what would be these 2 digits? I have to make sure this would be as low as possible. These 2 digits must be as low as possible. So if I start my carbon chain like this, if I start this as carbon number 1, this would be carbon 2, carbon 3, and finally carbon 4. My first double bond comes at carbon 2, and my second carbon double to carbon double bond, this carbon to carbon double bond starts at carbon number 3. So the first carbon double bond is starting at carbon number 2, and the second carbon to carbon double bond starts at carbon number 3. So my two numbers would be 2 and 3. Now let's say that I start numbering my carbon atoms from the left, meaning this is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. That means my first double bond will happen at carbon number 1. Therefore, the first X is 1, and my second carbon to carbon double bond starts at carbon number 2. So this would be carbon number 2. And you can see, since this number is lower, I'm going to start my numbering my carbon atoms from the left to the right. So these 2 digits would be 1 and 2. So finally, my parent carbon chain is but because there is 4 carbon atoms. My 2 digits would be 1 and 2 because there is 2 double bonds, and this is the least number I'm getting, and diene is the stem suffix. The last thing that you need to know is suffix or a functional group. There are a number of suffixes you need to know. Let's start with the OL suffix. OL is for alcohol groups. So you can see that there is an OH and attached to a carbon atom. Therefore, this is an alcohol functional group. So it will have the suffix OL. This right here has a carbon with a single hydrogen bond and a C double bond O. So therefore, this is an aldehyde and it will have an Al suffix. This is a ketone because the carbon has 2 carbon atoms bonded on either side and a C double bond O. And this is an opic acid suffix is used for carboxylic acids. Let's name this organic compound. In the displayed formula, you can see there is 2 carbon atoms. So the stem or the parent carbon chain is going to be eth. All the carbon to carbon bonds are single. There is no carbon to carbon double bond. So the stem suffix would be ane. And lastly comes the suffix or the functional group. You can see that this functional group is an aldehyde since there is a carbon atom which is bonded to a hydrogen, and this carbon atom has a C double bond O. So this is an aldehyde, and the suffix for aldehyde is Al. So I write eth, An, Al, ethanol. Let's do this example. My parent carbon chain, the biggest unbroken carbon chain, consists of 4 carbon atoms. So it's going to be but. The stem, therefore, is going to be but. I have no carbon to carbon double bonds. All my carbon to carbon bonds are single. So my stem suffix is going to be An. So I write An. And which functional group does this show? This is a carbon with a double bond O and carbons on either side. And this represents a ketone. A ketone has a suffix of one or on. So instead of this suffix, I write one. So one. I get but and on. Let's do this example. The longest unbroken carbon chain consists of 3 carbon atoms. So my stem is going to be prop. My stem suffix, since I have no carbon to carbon double bonds and all my carbon to carbon bonds are single, will be An. So instead of stem suffix, I write an, and the functional group or the suffix is going to be the alcohol group, this right here. And the alcohol functional group has the suffix ol, so I write ol. I get propanol as my compound name. So the last part of naming organic compounds is called suffix. I told you earlier that I will do this later because it's the most confusing one. So what is a prefix? A prefix is when you have more than one substituent or other carbon alkyl groups. Then we will write that first when we're naming organic compounds. The first prefix is CH3, which is surprising because CH3 is found in every carbon chain. But we don't write it as meth, eth, prop, but. We will write a prefix which is CH3 as methyl. Then comes the ethyl, which is CH3, CH2. Then comes propyl, which is CH3, CH2, CH2. Then comes chloro, which is chlorine. Bromo is bromine, and hydroxy is an OH group. More than one prefix is present, meaning if I have a chlorine as well as a bromine as well as a methyl group, we will write in alphabetical order. That means bromine B comes before C and C comes before M. So I write bromo first, then I write chloro, then I write methyl. Let's do an example. I have a 3-carbon chain displayed formula and a structural formula. And you can see that since I have 3 carbons, it will be prop, right? I have no double bonds. All the carbon to carbon bonds are single. Therefore, I will put an right next to the stem. The stem is prop. The stem suffix is an. And the functional group, which is this right here. This is the functional group. And since there is a H and a double bond O attached to a carbon, this is an aldehyde. And aldehydes have the suffix as al. So instead of the suffix, I'll write al and I get propanal. But here comes the tricky part. This chlorine is also present. And what's even more trickier is you have to write the digit or the number. When you write the digit for the double bond or for the functional group, you also have to write the digit or the number for the chlorine. You have to tell the positioning of chlorine. So where do I start? Will I start from left or will I start from the functional group from the right? Whenever you have a prefix and a functional group, the functional group will always be favored. Functional groups are always superior to the prefix. So we start from the position of the functional group, making sure that the position of the functional group is as low as possible, and then we reach the prefix. So this chloro, since it's chlorine, I write chloro. Since I start from the functional group first because I want the lowest possible position of the functional group, I start from the right. This is carbon number 1, this is carbon number 2, this is carbon number 3. So chlorine is on carbon number 3 because I want my functional group to be as low as possible and I don't care about the prefix. So chloro is on carbon number 3. I put a 3 and a dash because it becomes 3-chloropropanol. Let's level up our game and solve harder questions. Let's start with the first example. The longest unbroken carbon chain is of 3 carbon atoms. Therefore, this is going to be prop. Next, do I have a C double bond C? I don't. All of my carbon to carbon bonds are single. Therefore, I will have an as my stem suffix. Next comes the functional group, which is right here. But what is this? Well, it's an alcohol group and I have a carboxylic group. So what do I write? Do I write the alcohol or the carboxylic acid? Remember that whenever I have these two, I will always favor carboxylic acid, and I will explain in a second. So this carboxylic acid will be written as the functional group or the suffix. Instead of suffix, I write, and I want my functional group to be at the lowest possible position. So if I start with this as my first carbon atom, this will be my second carbon atom, and this will be third. And since this is the least carbon atom, and I want my carboxylic acid to be on the least carbon atom, so I start from the right. Now, what do I do with this OH? I told you earlier that an OH group is a prefix, which is known as a hydroxy. Whenever I have a carboxylic acid and an OH group, I write the functional group or the suffix as the carboxylic acid, and the OH group is not written as alcohol, it's written as hydroxy. So this hydroxy comes first. Since I started with the functional group as at carbon number 1, I don't have to mention the position because it's at carbon number 1. But the hydroxy group is at carbon number 2. So I write 2-hydroxy propanoic acid. Let's do this example now. So what is my longest unbroken carbon chain? It can be this, right? Because this is carbon, I can say this as carbon 1, 2, 3, 4, or I can do this, where this can be my carbon 1, 2, 3, 4, or I can also say 1, 2, 3, 4. But which one is right? Either way, the longest unbroken carbon chain is of 1, 2, 3, 4. If I start from here, or if I go from here, both ways give me a longest carbon chain consisting of 4 carbons. So I can do both. But for the sake of the argument, I will take this as my parental chain. Now, what do I do with this? I said earlier that a CH3 is a methyl group. So this will be called a methyl group. But I also have an OH. This time I won't say this as a hydroxy, but this will be an alcohol. Hydroxy is only used when I have an aldehyde ketone carboxylic acid and an OH group. So the OH will be written as hydroxy, and the rest of the functional group, be it ketone, aldehyde, or carboxylic acid, would be written as it is. Now, since I don't have any functional group here, I have an OH, this will be my functional group and not my prefix. This will be a suffix. So my longest unbroken chain is like this, and it consists of 4 carbons. So I write but. Next, do I have a double bond? Yes, I have a double bond. My double bond is right here. And do I start from here, from the left, or from the right? The functional group is always superior to everything, be it the double bond, be it the prefix. The functional group will always and must have the least numbering position. So I number my alcohol so that it has the least numbered position. Let's say this is my carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. That means my alcohol is on carbon number 1. But say I start my numbering from this carbon. Let's say this is carbon 1, this is carbon 2, carbon 3, and carbon 4. Now my alcohol is carbon number 4, which I don't want. So I start my numbering from this side because this side has the functional group and I want my functional group to be the least numbered. So this is carbon 1, this is carbon 2, this is carbon 3, carbon 4. Next, I have written the stem here. This is the stem. Next comes the stem suffix, which is the double bond. And since this is a double bond, I will write an en, En. And I also have to mention the positioning. This double bond is starting at carbon number 2, so I write 2. I put dashes in between. Next comes the functional group. Functional group is the OH or the alcohol, and alcohols have the OL suffix. So I write OL. Now, only thing left is the methyl group, CH3. And the methyl group is the prefix right here. This is the prefix. The methyl is a prefix. And my methyl is on carbon number 3 right here. So I write methyl. But I will also mention the positioning, which is on carbon number 3. Therefore, this is 3 dash. I get my final answer as 3-methyl but 2-enol. Now, I have an organic compound, an alkane, but this alkane has so many carbons. You tell me, which one is the longest unbroken chain of carbon atoms? Is it like this? Or is it like this? Or is it like this? I want my carbon chain to be the longest, meaning it must have the most number of carbon atoms possible and it must be unbroken. Unbroken means it must be in a straight line, meaning like this or like this. It cannot be like this. This is not a carbon chain. This is wrong. So now I will start from here. This is 1, 2, 3, 4, 5, 6, 7. This method gives me 7 carbon atoms. So this is the first possible carbon chain I can have, which consists of 7 carbons. The second carbon chain, it can be like this, or it can also be like this, but both ways give me the same number of carbon atoms. So this is 1, 2, 3, 4, 5, 6. I'm getting 6 carbon atoms. Since this is more than 6, this is 7 carbon atoms, I will choose this or this way. So this is not the answer. Another way is like this, which consists of 1, 2, 3, 4, 5, 6, 7 carbon atoms. And again, this is similar to the first carbon chain that I drew. So I can say that this is another way of drawing a carbon chain. Let's combine everything we know and do this last final example before ending the video. How do I name this? Pause the video and solve the question. First, I look at what I have. I see a double bond right here. And I also see this methyl group. How do I say that this is a methyl group? Well, this is the longest carbon chain. Well, someone might say, why can't this be the longest carbon chain? It can be like this, but there is this double bond right here. And the general rule is that I want my positioning of this double bond to be as low as possible. So first comes the functional group. Second comes the double bond. And finally, third comes the prefix. So my functional group, I make sure first that my functional group is as low as possible. Then I look at my double bond. If my functional group is as low as possible, then I look at my double bond. If my double bond is as low as possible, finally I will look at my prefix. So I have a double bond and a prefix. My double bond will be favored more than my prefix. So I want my double bond to be as low as possible. So if I take this as carbon 1, carbon 2, carbon 3, carbon 4, my double bond comes at carbon 1. And the methyl group, the methyl is coming at carbon 2. Well, let's say I start my numbering from this carbon right here. This is carbon 1, carbon 2, carbon 3, and carbon 4. Well, my double bond is now starting at carbon number 2. This cannot be bigger than my methyl group. I want to make sure that my double bond is favored when I have a prefix. So I number my carbon atoms like this. This is carbon 1, carbon 2, carbon 3, and carbon 4. Now I have 4 carbon atoms in my longest unbroken chain. Therefore, this is but. Then I look at my double bond. My double bond is at carbon 1, so I write a E and E. I will not write the positioning because this is already at carbon number 1. Then I look at my methyl group. The methyl group is at carbon number 2. This is carbon number 2. So I write a methyl group as my prefix. But I will also show the positioning. Since it's in carbon 2, I write 2 besides methyl. And finally, I get 2-methyl butene.